بسم الله الرحمن الرحيم. أبناء طلاب الصف الأول الثانوي، النهاردة إن شاء الله هنشوف lesson 1 من unit 4. lesson 1 is the work done. What is meant by work done? If you acting on a body by force and you can displace the body from its position, then your force is doing work. So work done can be defined as it is the dot product of acting force on a body by the displacement covered by the body. Then the relation W is the work done equal force dot displacement. We know that force is vector quantity, displacement vector quantity, but the dot product of two vector quantities gives scalar quantity. So work done is a scalar quantity because it is the dot product of two vector quantities. The measuring unit of work done is Newton by meter, which is called joule, and may be equal kilogram meter square per second square or kilogram meter square second power -2. So the dimensional formula of work done m L power 2 T power -2. And from the first term we know that the dot product of two vectors can be written as the formula multiply of the magnitude of the two vectors by the cosine angle between them. Then work done equal FD cosine theta, where theta is the angle between the direction of force and the direction of displacement as shown in figure. And we can define the joule is the unit of work done made by force 1 Newton to displace a body 1 meter through its direction. Now we will explain an example to show the properties and special cases of work done. Let force of 10 Newton displace the body 5 meter. Find the work done if the direction of force in the same direction of displacement. Number 2, direction of force at angle 60 degree to the displacement. Number 3, the direction of force perpendicular to the direction of displacement. Number 4, the direction of force at angle 120 to the direction of displacement. Finally, the direction of force opposite to the direction of displacement. The given of this example, F equal 10 Newton, displacement equal 5, and the rule of work done is FD cosine theta. Number 1, as the direction of force in the same direction of displacement, it means that angle theta equal 0, and then work done 10 times 5 cosine 0, which equal 50 joule. Number 2, the angle between direction of force and displacement equal 60 degree, then work done equal 10 times 5 cosine 60 equal 25. Number 3, as the acting force perpendicular to the displacement theta equal 90 degree, then work done equal 10 cosine 90, 10 by 5 cosine 90, which is equal 0. Note that work done is positive as theta is acute angle between 0 and 90 degree, and work done vanishes when the direction of force perpendicular to the direction of displacement. For example, the positive work done is the work done by your weight when you moves down ladder, and work done vanishes such as the work done by the centripetal force, and so your weight when you moves in a horizontal road. Number 4, when the angle between direction of force and displacement 120 degree, then work done equal 10 by 5 cosine 120, which is equal -25, and when force opposite to the direction of displacement, angle theta equal 180 degree, and work done equal negative 50 joule. It means that work done may be negative when the angle between the direction of force and displacement is obtuse angle, such as work done by the friction force, resistance force, braking force, your weight when you move up ladder. In all cases, work done is negative because the direction of force opposite to the direction of displacement. Then the notes: work done reaches maximum or positive maximum value when the direction of force is the same direction, when angle theta equals 0. Work done positive if the angle between direction of force and direction of displacement is acute angle, theta between 0 and 90 degree. Work done vanishes or equals 0 when the direction of force perpendicular to the direction of displacement. Number 4, work done is negative when the angle between the direction of force and displacement is obtuse angle. And finally, work done reaches to negative maximum value when the direction of force opposite to the direction of displacement. Now we will solve some problems on the work done.